In this lesson, we're going to look at calculating sine, cos and tan without a calculator. Now there needs to be some sort of starting point, so we're going to give you what sine x is as a fraction or a decimal, and then ask you to work out cos and tan from that. Now this technique is really useful, particularly at higher maths where it's expected you know this already. So let's have a look at it. So we've got an example here. I've got my three trig graphs there. I've got calculate cos x between 0 and 90, that's what this means. So that's an acute angle if you like, when sine x is equal to 0.8 without a calculator, so I can't inverse sine and things like that. So I have to pick out information that I know. So the first thing is that I'm going to try and turn this into a fraction. It's much easier to deal with in a fraction. You'll see why in a second. Now I know 0.8 is 8/10. That's units and that's tenths. So I'll write it as 8/10. Now, I also know that 8/10 is 4/5 if you simplify it, divide the top and the bottom by 2. So that's 4/5. Now, in this wee set of lessons, it's expected you know how to label a triangle. If you don't, you need to look back at your basic trigonometry, but your hypotenuse is opposite your right angle, your opposite is opposite the angle, and your adjacent is below the angle, if you like. I always memorise these two, and I can fit in the adjacent at the bottom. It's also expected that you know SOHCAHTOA, like sines opposite over hypotenuse, cos is adjacent over hypotenuse, and tan's opposite over adjacent. These things are expected. Again, maybe go back and look at basic trigonometry lessons if you're not sure of those. So sines opposite over hypotenuse, I know that as well. So what I can do here is, with my triangle, I can fill in information because I know that if sine x is equal to opposite over hypotenuse, and I also know that sine x equal to 4 over 5, that means the opposite side of this triangle must be 4. So I can fill that in. And it also means in the triangle the hypotenuse must be 5, because that's at the bottom there too. Now here's another thing that's kind of expected, is that you know how to do Pythagoras. Okay, so it's a right angle triangle, we can work out this one at the bottom using basic Pythagoras. Now it's good to know some Pythagorean triples. So for example, this is a 3, 4, 5 triangle. But if you couldn't do that, you would just do 5 squared, take away 4 squared, and then square out your answer to get 3. So it is a takeaway because you're working at a shorter side. But that's quick Pythagoras work there to get the 3. Now I can answer the question. So calculate cos x. So cos x is equal to adjacent over hypotenuse. And now that I've filled this triangle in, the adjacent side is 3 and the hypotenuse side is 5. So that would be 3 over 5. That would be fine. You could change that to 6 over 10, which is 0.6 if you really wanted to. Okay, let's look at another idea, very similar to what we did before. So calculate sine x when cos x is equal to 0.6 without a calculator. So again, I know 0.6 is 6/10, 6 over 10. I can simplify that down to 3 over 5, just divide the top and bottom by 2. And I also know that cos x is equal to adjacent over hypotenuse, so I can draw a wee triangle out, and from this information I know the hypotenuse is 5 and the adjacent side is 3, that's the bottom. Again, from Pythagoras or Pythagorean triples, you can go 3, 4, 5, or 5 squared is 25, take away 3 squared is 9, which leaves you 16, square root it, and you'll get 4. I can then answer the question, sines opposite over hypotenuse. Now the opposite side is 4, and the hypotenuse side is 5. Okay, right, I've got 4 more examples to look at. So this time I'm going to start with a fraction. Okay, so we've got sine x is equal to 4/5 and angle x is acute. Now I'm going to look at the graphs a wee bit for this one. So acute angle means between 0 and 90. So I've got sine x is 4/5, so up here somewhere between 0 and 90. Find the value of cos x. Okay, right, the other thing I'm going to look at here is this idea of the 4 quadrants, all sine, tan, cos. Because I'm dealing with an acute angle, and we will move on to obtuse, we are in the first quadrant between 0 and 90 here, between 0 and 90, between 0 and 90, and between 0 and 90. That's the first quadrant. So when I'm drawing out my triangle, I can still use the same information here. I know that sine's equal to opposite over hypotenuse. So my opposite side I can put 4, and my hypotenuse side I can put 5. And using your Pythagoras again, 5 and that'd be a takeaway, and you would get 3 here. And I can work out the value of cos. So cos x is equal to adjacent over hypotenuse. And adjacent side here is 3, and the hypotenuse side is 5. Now just to remind ourselves here, in the first quadrant, sine is positive. That's what that all means. And you can see the graph is positive there. And in the first quadrant, in the cos, which is an acute angle if you like, we're still positive, which is here. And we've got a positive answer, so that makes sense. Again, in the first quadrant here, we're looking for tan x, because the angle is acute. So tan we know is opposite over adjacent, and I can use the same triangle here to go 4 over 3. I can finish off. Now it's tan x is also positive answer here. If we look in the first quadrant, acute angle, tan is also positive. It's above 0. Now this will make more sense when I do the obtuse angles. Right, let's just do one more acute angle question. I'll do it quite quickly because it's very similar. So cos x is equal to 3/5. And angle x is acute. Find the value of sine x. So you would draw your triangle out. We know that cos is adjacent over hypotenuse. The adjacent side must be 3. The hypotenuse side must be 5. And then you've got a 3, 4, 5 triangle using Pythagoras again. That must be 4. Okay, so to get sine x, that will be opposite over hypotenuse. So that's 4 over 5. There we have it. And again, you can change that into decimal, 8 over 10, 0.8 if you wanted to. And to find the value of tan, use the same triangle, which is opposite over adjacent, which would be 4 over 3. Okay, right, let's look at when it's obtuse, which is a bit more complicated, but important to understand. So, let's say sine x is equal to 3/5 and angle x is obtuse. This means we're working out this angle here, an angle bigger than 90. Now I'm still going to use a wee right angle triangle to work out my relative acute angle, because I want to work with that relative acute angle, which will then help me get what the value of x is, or the value of cos x in this case. Right, so let's have a look. So we'll draw our triangle out as normal, and we'll fill in the information. I know sine's opposite over hypotenuse. The opposite side is 3, and the hypotenuse side is 5, and I can use Pythagoras to get my 4. Now I know that cos is adjacent over hypotenuse. But here's the thing. Because we're dealing with obtuse angles, we're no longer in the first quadrant, because the first quadrant is 0 to 90. They're acute angles. We're dealing from 90 to 180, or in this all sine tan cos, or cast diagram, whatever you call it, we're in the second quadrant. Now in the second quadrant, only sine is positive. You can see it here. This bit, sine's positive. When you're dealing with cos, it's negative. When you're dealing with tan, it's negative. So when you fill in your information for cos, you put adjacent over hypotenuse, which is fine, which is 4 over 5. But it's negative 4 over 5 because you're in this part here. Signified, similar to trig equation work, signified by the S, which means only sine is positive. Let's look at tan. So tan we know is opposite over adjacent. So it would be 3 over 4. But again, because we're in the second quadrant between 90 and 180, because our angle's obtuse, we're going to have a negative value of 3 over 4. And again, if you look at this graph up here, you can see tan between 90 and 180 obtuse angles is negative. So you can do your normal trig work with your triangle, but just you've got to decide whether the answer is positive or negative. I'll do one more. So, final one, cos x is equal to negative 3 over 5, and angle x is obtuse again. Find the value of sine x. Now, when you're drawing your triangle out, I would advise you to use the positive values. Just ignore the negative. When you're using the relative acute angle, you always work with the positive values. So, find the value of sine x. Now, we know that cos is adjacent over hypotenuse. I'm just going to use the adjacent side as 3 and the hypotenuse side is 5. Again, I can fill in my triangle 3, 4, 5. Okay, when I'm looking at sine, I know that sine is opposite over hypotenuse. So opposite over hypotenuse is 4 over 5. I'm now going to decide if it's positive or negative. Now in the second quadrant, there's an S, which means sine is positive. If you look at the graph, for an obtuse angle between 90 and 180, sine is positive. So I'm going to keep it as positive 4/5, and that's my answer. When you move to tan, tan is equal to opposite over adjacent. You look at your triangle, and the opposite side's 4, adjacent side's 3, so it would be 4 over 3. But we're in the second quadrant, and only sine is positive there. So it's going to be negative 4 over 3. And again, if you look at the graph here, between 90 and 180 obtuse angles, which I'm dealing with here, tan is negative, so that makes sense. This is quite a tricky concept, so I'll maybe replay the video, have a think about it again, go and practice these questions, because it is quite a challenging area here. You have to know quite a lot. Pythagoras, basic trigonometry, your trig graphs, there's a lot going on.